Okay, here we go. This is the last proof that we're going to do. We're going to start with the proof this time. This one's a little bit different. You could do it the same way, but we're going to show, we've seen enough of those formal ones that we can do something a little bit differently this time. And since we've proven the product rule formally, I think that this is fair. And remember, this is what we were kind of just talking about. If F is P times Q, F prime is not P prime times Q prime. Right? And so don't you think if F is P divided by Q, do you think F prime will be P prime over Q prime? Even just thinking about how the relationship between division and multiplying by a fraction, that doesn't make any sense that this would be the case. If it's not true for multiplying, it's not going to be true for dividing, right? So what is true? Let f at x equal p at x divided by q at x. I'm going to give you a hint. We're going to use product rule to prove this. So what do you think we want to do? As a first step for this proof. But I don't have a product yet. Sarah? Move it over to the other side. Very nice. Anybody else thinking that same thing? No? F at x times q at x equals p at x. Anya, now what can I do? Now we can use the formula that we know, can't we? So p prime is f prime times q plus q prime times f. Now, generally speaking, what do we want to do? What do you think? Anybody have an idea? Generally speaking, what do you think we want to do? To prove it, what do we have to solve for? We have to rearrange this so that it says f prime at x equals. There's one other thing that we have to do that's maybe a little bit trickier to think of. We probably want to swap out the f at x. What can I swap that out for? Yeah, the definition of the function, right? Very nice. OK, so p prime at x equals, actually, I'm going to do two things at once. I'm going to move the q prime and f prime to the other side. So I get p prime at x minus q prime of x, and then I'm swapping the f at x. Now what? Let's wait a minute. I'm going to get a common denominator on the left side. So I'm going to get a denominator of q at x. So this is going to be p prime x qx minus q prime x px over q at x. Now I'll divide by q, and I'm going to rewrite it like this. And there you go. That's the version that we want. Okay, so if f at x equals p at x over q at x, then f prime equals, this is how we sort of think of it or like say it or start to memorize it, the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So that was why if you did it that way in the learning goal, it didn't work. Because it's not just the derivative of the top over the derivative of the bottom, it's something much more complicated. Any questions about that? So starting tomorrow, we do 2 days on what's called Simplify Fully. So there is stuff that we're going to want to do with derivatives starting in the next unit in particular, where we don't want a big, nasty expression. We have to simplify it. And when you use the quotient rule or the product rule, you generally get something that can be simplified nicely. It's a fair bit of work. And so, you know, we spend a couple of days kind of figuring it out. But it's more good practice using product rule and quotient rule and that kind of stuff as well. All right, so let's use this a few times. So I'll call this P on top and Q on bottom. And just like we did before, P prime, like I'll do this off to the side. Again, if you're struggling and making mistakes and trying to get through it, but then finding that your answer is not right when you check the answer, this is what I would do. I would be doing derivatives of different parts off to the side so that I've got an expression, and then using the formula with that already done. Because when you're trying to use the quotient rule formula and trying to take derivatives at the same time, when it's something you're not used to, it ends up being more than your brain can handle. And that's when you start to make mistakes. So what's the derivative of p? What's the derivative of the top? Just 5. And the derivative of the bottom? -2. Very good. So y prime is the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. So for the quiz, you would be able to stop there because you don't have to simplify. But because this one's fairly easy, I'm going to do it anyway. So 4 times 9 is 45 minus 10x plus 10x plus 14. I'll leave this the way it is for now, at least. Look at that. 10x minus 10x, they're gone. So 45 plus 14 is 59. And there will be, so that one simplified nicely. There will be times where you are required to simplify just by the instructions of the question. But there will be other times where you're not required to simplify. But you got to decide whether it's worth it or not. Like I'm looking at that and I'm saying, yeah, it's worth it to simplify this. Not even knowing that the x's on top were going to be gone. Just knowing that it's a constant times a binomial. It'll only take me 1, maybe 2 steps to do this, and it's going to give me something simpler to work with. And because in the next unit, we're going to start doing things with the derivative, not just finding equations of tangent lines, doing other things with it. If all you were doing was finding the equation of a tangent line or slope of the tangent line, I mean, you could plug it into that or that or that. Like you can plug it into any step and get it, right? So is it worth it to simplify or not? And this is an example of when it is. But I don't want you to, I don't want people to overcomplicate, and particularly tomorrow when we start doing simplify fully, and then all of a sudden the questions are, well, how far do I have to simplify? Or what do I have to do? Or what does my answer have to look like? Like these are the questions that we get kind of bombarded with. And I understand it's expected. But like there's sort of 3 different situations. The quiz, where you're just simplifying monomials on negative exponents. Okay, so we call that like first line derivative only. You just take the derivative of the first line, clean it up a little. There's simplify fully. And you have to simplify fully when the instructions say simplify fully. If it doesn't say, then it's up to you. It's your call. You decide. So there's sort of those 3 situations. What do you think about this one? There's something that's worth noticing about this one. Yeah, you could. And good idea. I think that's the right thing to do. What if you didn't?
Couldn't you still do it? You just have to get the derivative of t, which would just be wrong.
Well, if I'm doing the derivative of the top times the bottom, that's fine so far. Minus the derivative of the bottom. How do you take the derivative of the bottom of this? You'd have to do product rule. So you'd be doing product rule inside a quotient rule question. This is something that could happen and could come up. But that's why it's a bad idea, and it's a better idea to distribute in this case, because it's going to be easier to take the derivative of the bottom. I mean, the bottom, even using product rule, wouldn't be too bad because it's just like the derivative of t is 1. But it would still be a lot more work, right? So again, it's all about efficiency. It's all about, to some extent, your preference, your personal preference, and how comfortable you are with different kinds of math. For example, you might do a question one way because you try to avoid fractions at all cost, whereas somebody else might be fine doing a little bit of fraction math in their head. You know what I mean? And so you might do it 2 different ways, and that's fine. But you've just got to know yourself and what you're good at, where your strengths are. And the real thing is, a lot of people wouldn't think of this as a product. And so I don't know what they would do. They would probably just take the derivatives of the parts separately. And you would just do derivative of p times derivative of q, which is wrong. You know what I mean? When it's inside another question, people don't recognize it for what it is. So, derivative of the top. 2t minus 4. And oh my goodness, that better be in brackets, right? There's another mistake that people make. Times the bottom. Minus the derivative of the bottom. Go ahead.
Negative 2t plus 7.
Times the top. All over the bottom squared.
Shouldn't it be plus?
Minus. Formula is minus.
Oh, this one.
Yeah. It was plus in the last one because the derivative was negative 2, so I changed it to plus.
Oh,
Yeah, and I didn't mention that. But the formula is minus, right? So this is a good example of something that could be cleaned up, but I'm not going to worry about that right now. We're going to move on. Good? It was there and I lost it. There it was. Okay, once again, what do you think? Expand the top first. So go ahead and do that. So you should get that part. And that's what I got. I put my derivatives in green so that they stand out a little bit in case somebody's following this on their own kind of thing. People get that on their own? Nice. Okay. Find the points on the curve where the tangent line is horizontal. What does that mean? Slope is 0. Very nice. Calculus is hard because there's all these little details all throughout that you have to be mindful of. There have been questions in the practice where it's like parallel to this line. And you got to realize that means you got to find the slope. Like there was one in particular that it was in standard form. So you got to put it in y equals mx plus b form to get the slope and then realize that parallel slope or parallel lines mean same slope. Like all these little things. I mean, that's grade 9 stuff, but there's just so much of those little things in calculus, and that's sometimes where people mess up, right? You are focusing on taking derivatives and you forget about the other silly little things, and just so many different places that you can make mistakes. So this one we don't need to clean up. I think we're going to just take the derivative. Does that sound right? Yeah? X cubed minus 16, yes. Yep. Are we okay with that, taking the derivative? So go ahead. So this is what I got for my first line. Now, because we're doing something with this derivative, this is a place where it's worthwhile to simplify that top. So this works out to, that's obviously just x cubed minus 16 minus 3x cubed so I got negative 2x cubed minus 16 over x cubed minus 16 squared. Now what? Anybody? Megan? So we set that equal to 0 because we're trying to determine where this function has a horizontal tangent line, or in other words, the slope of the tangent is 0, is where this expression will equal 0. There's kind of a joke in calculus that if you ever come across a question, you know, on the final exam or some test, and you're not sure what to do, try taking the derivative and setting it equal to 0 and see what happens. Because that's like, you're going to find that we do this over and over and over again. We're constantly setting things equal to 0 and solving, and that tells us something about the original function, okay, which we'll get into more in the next unit. So if and then you're going to So I'm going to say slope of the tangent equals 0. So negative 2x cubed minus 16 over x cubed minus 16 squared equals 0. Sir, you had your hand up? Did you want to say something? Or? Yeah, like that. Now what? Where's that from? Again? Like, where'd you learn how to do that? Yeah, but how do you know that? Where do you, like, didn't we do all of this in MHF? Right? That's like if you ever wonder why we learned the stuff we learned in MHF, I mean, there's one reason, because now we need to know how to solve a rational equation. I need to know how to figure out when this is 0, which is when the top is 0. What happens when the bottom is 0? Vertical asymptote, right? Vertical asymptote of this, not of that. People start to get confused about what they're doing work on the derivative and what are the properties of the derivative versus what are the properties of the function, right? We're probably not there yet, but so negative 2x cubed minus 16 equals 0. So there's lots of different ways you could solve this. I'm going to solve it like this. And it says find the points so it was x, so negative 2 over negative 2 cubed minus 16. Negative 2 cubed is 8 minus 16 is negative 24, so 1 over 12. Tangent line is horizontal at negative 2, 1/12. Any questions? We're going to do one more. Okay. And I'm just going to keep saying this over and over and over again. It might look easy, but trust me, folks, it's not. So many places that people can make mistakes. Here's another one where you're looking at it and you think, oh, it's quotient rule, and you don't realize that there's a product on top, and you'd have to do the product rule unless you expand first, which is obviously what we're going to do. But again, like, I think people sit there and think that won't happen to me, and it does happen to you. Mm-hmm.
Would there ever be a case where we aren't allowed to expand it?
I can't think of a time where I just forced it on you and said no expanding allowed or anything like that. But there are questions where it would be too hard to expand the top. So you wouldn't. You'd have to do product rule and a quotient rule. Okay. So S equals 8t to the 6th minus 24t to the 5th what have I done here? 24 t to the 5th. Okay. Derivative of the top. 48t to the 5th minus 24 times 5. Is that 120? 120t to the 4th times the bottom. Minus derivative of the bottom. What do I have to do for the derivative of the bottom? Megan?
Bring the 2 up front and then multiply the function by its derivative.
By the derivative of what's inside. Power of a function, we call that rule. It's got another name called chain rule, which we'll talk more about at another time. So, very good. So bring the 2 down. T squared minus 4 to the 1 times the derivative of what's inside, which is 2t. All of that times the top. T squared minus 4 all squared is t squared minus 4 to the 4th. Yikes. I'm going to clean this up a little bit.
For the denominator, all we do is we square the denominator, right?
Yeah. Good thing it's when t is equal to 1, because if t was equal to anything else, we'd be in a bit of trouble. So 2 times 2t is 4t times t squared minus 4 times 8t to the 6th minus 24t to the 5th. The hard part about calculus isn't the calculus part. Like for the most part, you can memorize the product rule and the quotient rule. Now, like I said, there are places where people apply them wrong or miss that it's a product rule question. That's not the hard part. It's doing the actual algebra that's the hard part, not dropping a negative or an exponent or something somewhere. I'm going to just point out what our lesson tomorrow is going to be about. Notice that I've got 2 terms here. I've got this on top. I've got this and I've got this, right? I've got something minus something. Now, for the quiz, this would be good. I cleaned up the monomials because I took the 2 and the 2t and made it 4t. That's required for the quiz. That's pretty much always required. You're going to have to clean up monomials when you take derivatives. Okay? For the quiz, it'd be done. But after the quiz and for the test and moving forward, because tomorrow is simplified fully, look what I have. I've got a t squared minus 4 and a t squared minus 4. I can factor that out of both. And I can cancel it with one of the t squared minus 4s on the bottom. So then that's where we start to be able to simplify further and tidy it up a lot more. Okay, and so that's the kind of thing that we're going to be doing down the road. But for now, I'm going to find s prime at t equals 1. And it's going to be 48 times 1 to the 5th minus 120 times 1 to the 4th times 1 squared minus 4 all squared. Okay, I'm going to let you try to evaluate that. So I plugged in all the ones. They all kind of disappear. 48 minus 20 times 9, because 1 minus 4 is negative 3 squared is 9, obviously. This is negative 4 times negative 3, which is positive 12, so plus 12 times 8 minus 24, which works out to negative 840 over 81, or negative 280 over 27. Yes?
Question like this on the test, can you just plug it into your calculator and get the right answer?
Yeah.
We don't need to show all of this.
No.
Just plug it in.
But because it's a 1, I would do this step. I wouldn't show those two, but I would do that one. It's easier to type in than all of that nonsense, obviously. Any other questions?